Hey everyone, this is going to be a quick tutorial on Haystack, an AI framework for building AI applications. If you guys have seen any tutorials on building RAG applications, you've probably heard of LangChain. LangChain is probably the most popular framework for new users. But here I want to introduce Haystack and show its capabilities for developing applications. So if you just go to the Haystack website, you should probably see a tab that says documentation. I'm going to follow through an example very similar to this one right here called creating your first QA pipeline with retrieval augmentation. Um, and here they use OpenAI, they use in memory stored for the vector store, document vector store. I'm actually going to use Google Gemini, and then I'm also going to use center transformers for the embedding. So unfortunately, I wasn't able to run this on my laptop. I had to upload this onto my GitHub. If you guys want to follow the code, just go to my GitHub repo. Should be under Haystack tutorial. There should only be one notebook there. But to elaborate on what we're going to go through, I'm going to be using Gemini for the LLM, Pinecone for the vector store, and I'm going to kind of walk through a simple example that, again, is pretty similar to what they set up here, but slightly different, showing some of the differences in different capabilities. So I downloaded a sample data set from Pinecone called Refined Web Generated Questions version 1. And in this data set, we have a document ID, we have document text, generated question, and generated answer. So we have questions, we have answers, and we have reference text that are used to answer those questions. So if we randomly sample one of these questions, the question is, what animal inspired scientists to develop a sound dampening technology for use in wind turbines, airplane wings, and computer fans? And the answer was owls. If we look at the text, it talks about how owls inspired this technology. And now if we ask a generative model this to answer, give us a response to this question. In this instance, it said the animal was a bowhead whale, which is incorrect. So why did this happen? LMs have a limited knowledge and context. And in order to fill in those gaps, we use RAG. And in this notebook, I've also linked a few videos here explaining what RAG is. I won't really go into too much detail, but I'll quickly walk through what the general flow of a basic RAG application might look like. So it might start out with a user query. We take that query, we have an embedding model, we create embeddings, then we do similarity search against a document store. We retrieve relevant documents, embed that into a prompt that then gets passed into a large language model, and then that model generates a response. So literally, this is just like, if you can almost think about it as an ML pipeline. Like there's a flow to this and an expected outcome. So not Pinecone, Haystack developed something called pipelines, and this is basically we're going to design and walk through how these pipelines can produce a RAG application. So I have some documentation here on the embeddings model itself. I'm going to kind of skip through this part. You can read on it on your own if you'd like. I had to set up a vector store, document store to contain all of the vectors and text so that I could query my question against that. But here, I'll just quickly show that I test this this question against the vector store to see if it would retrieve the expected document. And If we look at output number 19, we can see that, yeah, we get this alt text piece that I showed above. So now let's get into actually like building the RAG application. Um, we'll need a prompt builder to house our prompt. This prompt uses Jinja, and if you're not familiar with Jinja, just do a quick Google search. The web framework Django is uses Jinja, but Jinja allows some flexibility in the how you can add text into your text strings. So you could see that I'm passing in those documents, and then I specifically want the content from those documents, not necessarily like the metadata, but just the content. Um, I instantiate the LM model here. Again, I'm using Gemini for my model for my generative application. I use Gemini 1.5 Flash, which is a fast LM. And I used a local model for uh, the embeddings. Um, Haystack uses this thing called pipeline, and we initialize a pipeline, and then we add components to that pipeline, and then we connect those components together so that they can flow through a pipeline. So we get input, and then out we should get an expected output. And if we do a simple print, you can see here that it lists out the different components. We have the text embedder, the retriever, the prompt builder, and the LLM. You can see here that each line defines what those components are and also how they're connecting. So let me just walk through the connection because I think this is actually pretty important. Sometimes can be a little confusing for new beginners. So first we receive a query. That query gets submitted to the text embedder, does the embedding, then it gets passed along to the retriever, um, and it receives it in this variable called query embedding. Um, the retriever does its thing, gets those relevant documents, and then passes it on to the prompt builder in this variable called documents. Next, the prompt builder returns an object, and that object gets returned to the LLM. So it goes in that sequence of order of basic RAG application process. So very similar to this diagram. So embedding, document store, documents prompt, and then LLM. Now, taking that same question that we started out with, we pass that into our basic RAG pipeline. Uh, we want this question to go through the text embedder first, and it takes it in as a variable called text. And then we also need to pass it into the prompt. Uh, and that variable is then question. So here you might see that, all right, here is question and here's text. These were predefined variables. The text embedder um, just by default wants it as a text, but question, we can look where we define that, and you can see here, I defined this variable question. So that's why you might see those differences. But anyways, the pipeline runs and we get a response, and it's owls. And finally, if we want to validate that what this flow looks like, Haystack allows us to visually see this flow, how each component in that pipeline connects. First, we receive a text query, uh, gets passed into the text embedder, does the embedding, passes it over to the retriever. We get some documents that gets passed along to the prompt builder, and then finally into the LM for a response. So that's basically it. That's a quick walkthrough of Haystack and how to build, again, a very basic RAG application. But I'm hoping to do more tutorials on this and kind of go into some of the basics, but also go a little bit beyond the basics of what you might find online for AI engineering. Anyways, hopefully this video was helpful to you guys. Thank you for watching.